in exciting times. In a world full of energy, life and activity, our living is made even more idyllic by the variety of gadgets, tools, services and solutions at our disposal. Undeniably, the world as we know it today would not exist without such convenience. To carry out such activities, energy is used, and electricity in particular plays a crucial role in facilitating this convenience. At the touch of a button, electricity works wonders in our lives. It makes lighting, cooking, entertainment, manufacturing, commerce, and a host of many other functions so flawlessly efficient, contributing markedly to our modern lifestyles. Against the traditional sources of energy such as charcoal, firewood, kerosene and others, the convenience of electricity is unequaled. The positive impact of electricity changes our perception towards life in a very real way, and we begin to yearn for the new and better lives that it brings. Fortunately, nature has provided us with a variety of sources from which we can obtain electricity. Natural movement of the wind, water or hot gases from the bowels of the earth can be tapped and converted to electricity through turbines. But have you ever stopped to ask yourself how electricity comes to your home, workplace, business or industry? Next time you turn on your lights or your TV set, pause for a moment and reflect on how far the electricity has traveled all the way to your switch. To understand how electricity is delivered to your home or premises, we have to start at the source. The Kenya Power and Lighting Company (KPLC) transmits, distributes and retails electricity that is generated from different sources, mainly from water, geothermal, thermal and wind.
We have to always ensure that the demand for power is matched with the generation. So our main objective is to get power generated from various sources, transmitted over the grid network, and finally availed to our distribution system for eventually delivering to our customers who need the power.
During periods of adequate rainfall, when the hydroelectricity generating dams fill up, the larger proportion of electricity in Kenya is generated from water. These dams are managed by the Kenya Electricity Generating Company (KENGEN), which is also the biggest power generator in the country. Hydropower plants have water stored behind massive dams. The water is used to drive huge turbines, which are connected to generators that in turn generate power. Hydropower has traditionally been the main source of electricity in the country.
The intake is where the water gets in to go and turn the turbines. Our dam length is about 11 kilometers. The water hasn't reached the spilling position, the level, but we are trying to regulate it so that when Masinga spills, we can fill the dam.
Hydropower plants managed by KENGEN include Masinga, Kamburu, Gitaru, Kindaruma and Kiambere on the Tana River, and Tarkwel and Sondumiriu plants in West Kenya. The company also runs a thermal station in Mombasa and wind turbines on Ngong Hills in Nairobi. KENGEN also generates geothermal power from its plants at Olkaria in Naivasha. Here, electricity is generated from the hot steam from the Earth's crust. Kenya's geothermal power is reliable, sustainable and environmentally friendly.
When the generation is done, we have an agreement, that is the power purchase agreement with the KPLC, where we sell all the power that we generate to KPLC and we deliver it to the high tension cables. Then it is sold. It is transmitted and distributed to the customers.
Thermal power is a more expensive type since it's produced by burning fossil fuels, usually heavy fuels, to generate electricity. Here, fuel is used to heat water and convert it into steam at high temperatures, and the steam then rotates turbines to generate electricity. Other thermal-based independent power producers, IPPs, include Savo Power and Rabai Power, both at the coast. During periods of power shortages, a country may contract emergency power providers to temporarily bridge the demand and supply gap. In the past, Kenya has engaged Aggreko, a British firm, to provide diesel generators to augment its national power supply. Mumia's cogeneration produces power from bagasse, which is a byproduct of sugar processing, whereas Ore Power 4 is a geothermal plant.
We generate steam for basically two main reasons. One, to produce electrical power to run the plant. Two, to produce steam, which is basically heat energy, to boil the juice and syrup. And the surplus power that we generate through the cogeneration power plant, we basically sell it to Kenya Power.
Once electricity has been generated, it is transported through high voltage transmission wires that run atop steel towers, otherwise known as pylons. The network of transmission lines is called the national grid. There is no known method of storing large quantities of electricity for distribution to customers, and therefore the amount of electricity injected into the national grid must always match the demand. The national grid is equipped with complex equipment to ensure that electricity supply is consistent and reliable. That is where the National Control Center comes in. This KPLC facility, located along Juja Road, Nairobi, controls the power transmission network throughout the country. Here, supply and demand are monitored to ensure adequacy, continuity, as well as quality of supply. And the engineers working here are on 24 hours duty to maintain this balance.
The demand somehow varies from time to time. Like during the night, it is low. It picks up around 6 a.m. and drops a little at about 7. So the controller has to follow that demand. When it rises, he puts in more machines. When it goes down, he lowers, or when it is so low, he even takes off some of the machines, like during the night.
Electricity conductors are made of metal, usually aluminium or copper, and steel wire for reinforcement. That is because metal is a good conductor and electricity travels through it easily. Electricity travels fast, about 310,000 kilometers per second. In order for the electricity to be transmitted safely and efficiently, it must be at high voltage or pressure and a low current. This is because if the current is too high, the cable would heat up too much and even melt. On the other hand, if the voltage is too low, hardly any energy would be transmitted from one point to another. The high voltages, usually 132,000 volts or 220,000 volts, are therefore necessary to push electricity through the wires.
When power is generated from various sources, for example, Seven Forks, where we get most of our power, we step it up, we step the voltage up, then we transmit along the transmission lines up to the big primary substations where we again step down to lower voltage.
As electricity gets near the customers, the high voltages are stepped down to 11,000 volts for local distribution. For domestic use, the power is stepped down further to 240 volts, bringing light, convenience, and a myriad other uses that delight our lives every day.